It's such a fun lesson here. Okay. You have to graph what's called the parent function of a line. Okay. That's y equals x is a parent function of a line. Then you got to translate the parent function. So you look at your parent function y equals x. Just make a table. And let's just go 2, 1, 0, negative 1, negative 2. We're not using this one. We're on this one. Okay, so if x is 2, y is 2. X is 1, y equals 1. I mean, I'm stating the obvious here. And then negative 2. So you graph them 2, 2. I don't care if they're labeled. I don't need them labeled. And right there, something everybody wanted to know. That's the parent function of a line. You're going to graph the parent. Now you do what's called translate it. What you do on a translation, you want to parenthesize just the x, and the minus 2's outside. That means everything goes down 2 units. Okay? So every point I have there goes down 2. And there you go. Okay? That's all you do. Okay? Next one, parent functions. Parent's the same. Okay? It's just 0, 0, 1, 1, 2, 2, negative 1, 1. You can recreate that table if you want. I'm not going to save time. But that's a parent function of a line. Okay? Plus 3. Well, that means we go up 3 with all my translations. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. I'm teaching this because I'm forced to. Okay? There we go. Pretty awesome, exciting stuff. Really serves a point, dude. Okay? I can barely contain myself. Okay? 0, 0, 1, 1, 2, 2. I like lots of algebra, but not really this translating function stuff. Okay? I mean, I get it, and I can teach it, but hard to see kind of the value in it. Okay, and this time I'm going to translate everything down 5.5. So 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5.5. Okay. 1, 2, 3, 4, 5. 5.5. 1, 2, 3, 4, 5. 5.5. Awesome, man. Great, valuable stuff. Okay, everybody, that's the answer to life's problems, dude. Okay, and so is this. An equation for each vertical translation of y equals f of x. Okay, basically f of x is just a funky name for y. It says y equals f of x. Here's all you do. You write y equals f parentheses x, and then an up-down translation means you just minus if it's down. That's the answer. And you add to the function if it's up. Write the whole thing, don't be lazy. Okay. Y equals f parentheses x minus 6. Now what do you do if it's left, right? Well, we're going to get into that. Okay. But for now, that's just vertical translations. Now the next part is even more kind of pointless. And make a table for f of x after the translation. So remember, f of x is just a glorified thing that people who should be probably punched. Nah, I shouldn't say that part. Okay. Call y. Okay, it's just another name for y. Translate it 2 units down. That just means the x values remain constant, and we just translate everything 2 units down, which means minus 2, not plus 2 like I was doing. You don't need to recreate the table. Just put 2, 6, 10, 14. I'm happy. Okay. Now I could make it rewrite it again and retrace all of them. I'm not going to do that. Okay. Now you have the function here. It's not a linear function. It's called a parabola function. If you had me 2 years ago, we graphed parabolas. Those are the U shapes. 5 units up, so that means all the outputs increase by 5 while the x's remain constant. It's all about vertical translations. Okay. Now, that's all about vertical translations. Now we get a new parent function, y equals x to the second. Translate the parent function. Okay, this is my parent here. It's not just y equals x anymore. It's y equals x to the second. So do the same thing. 2, 1, 0, negative 1, negative 2. If we take 2 to the second, that's 4. If we take 1 to the second, that's 1. 0 to the second is 0. Negative 1 to the second is not negative 1 ohms. Negative 1 to the second is positive 1. Anything to the second is positive, even if the base is a negative. Negative 2 to the second is 4. Now I want you to graph that. So 2, 4, 1, 1, 0, 0. Negative 1, 1. Negative 2, 4. You guys that had me 2 years ago, that should look familiar. Last year, Algebra 1 didn't get to it because of the quarantine. It's a U. Please make curves. It's not a V. Okay. V is for absolute value graphs, which we'll get into. Now you're going to translate the parent function, but you know on the first ones I was making a parentheses and the plus minus was outside. Well, this time it's inside. Inside is a right-left translation. Okay, but it's not what you think. A lot of people see the plus 3 and they're like, oh, I'll just take every point 3 units to the right if that's the way you're going to roll. No. Horizontal translations, remember, I'll go back to my paper. I made a parentheses for a reason. It was outside, it's up or down. Okay? Now it's in the parentheses, we're thinking left, right, but the horizontal, the left, right, the vertical is up and down, just like it says. Horizontal is actually the opposite way of what we see in the parentheses. So I see plus 3, I think this way, but guess what? It's the opposite way. I'll explain why here in a second. So I translate it left 3. That one, 1, 2, 3. 1, 2, 3. 1, 2, 3. Every point goes left 3. 1, 2, 3. And now I have a new function. Now let me explain why we do the opposite within the parentheses. The parent function at 0, 0. Okay? Well, if I go right 3, mean adding 3 to all my x's, that's going to make positive 3. Okay? 3 plus 3 is 6. 6 to the second is 36. It's not 0. Okay? Actually, I want you to do something else just for this problem. I don't need this done on the assignment. Label that point negative 3, 0. See, if I put negative 3 in for the x there, that's 0, 0 to the second, 0. Okay? So negative 3, 0. See, if I'd have done the wrong thing, don't write this down here. Okay? If I'd done the wrong, this is all I need you to write here, okay? All this junk, I'm just making a point. If I would have done the wrong thing and went right 3, okay, and would have put, 3, 0, that's wrong, because if I put 3 in for x, 3 plus 3 is 6. 6 to the second is 36. That's the wrong coordinate. It's not 0, okay? So basically, make a long story short, if it's in parentheses, it's a horizontal translation, but it's the opposite of kind of what you have in the parentheses. Okay, so next one, parent function. Just go off this one. So 2, 4, 1, 1, 0, 0, negative 1, 1, negative 2. That's your parent function. I want to see the parent function down. Okay. Now the translation, since it's in parentheses, we're thinking right, left. Now normally I think minus 5 that way, but it's the opposite. We actually go the other way because it's like you're trying to bring it back. Okay. So you'd have to translate everything right 5. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I'm going to explain again why I went right instead of left, because you think minus, oh, negative's that way. Well, it is, but, okay. 1, 2, 3, 4, 5, that'd be 5, 0. Now let's plug 5 into the equation and see if 0 is the output. 5 minus 5 is 0. 0 to the second, 0. Okay? See, if I'd have done the wrong thing and went the wrong way, negative 5 minus 5 is negative 10, and negative 10 to the second power is 100. Okay? That is why you go the opposite way. I pretty much just proved it. Okay? This is like the opposite of what you think. Okay? Positive, instead of right, you go left. Minus in the parentheses, instead of left, you go right. A lot of people get that confused, but I kind of just tried to show it why. Okay, again, if it's in parentheses with the x, it's a right-left translation. So the parents 1, 1, 2 of the x squared. Right there, I totally messed that up. Okay. That shouldn't be there. Okay. Okay, so minus. Now I think minus that way, but oh, better think again. It's the in the parentheses. It's the opposite. Okay. Let's see, every point goes forward too. 1, 2, 1, 2. You might run into a point you already have. They might intersect. That's fine. 1, 2, 1, 2. Okay. Now again, you can stop there. That's all I need on the assignment. Now I'm going to prove to you why I go forward 2 instead of backward 2. That's 2, 0. 2 minus 2 is 0. 0 to the second, 0. Perfect. If we went the wrong way, that'd be negative 2, 0. Negative 2 minus 2 is negative 4. Negative 4 to the second, 16. That's not a coordinate that works in that equation. Alright, now gets even kind of weirder. Write a function rule for each function reflected in the given axis. Here's what, you don't need to write this down, just observe, okay? Here's what a reflection does. It can be an x-axis reflection or a y-axis reflection. Let's say I have a graph that contains these points. Let's go 1, 3, I'll make it linear, 2, 6, 3, 9, okay? That's the original. Reflection in the x-axis means all your x coordinates go opposite, okay? That's how that's going to work. A reflection in the y-axis means all the y's would go to opposite, okay? Okay, so back to the example. You've got to write a function rule reflected in the given axis. If it's only the x-axis, here's what you do. Only the x term goes opposite. The minus 6 doesn't, okay? So f of x equals negative x minus 6. That's all you do. Now don't write this down, just watch. So the original function was f of x equals x minus 6. Remember, y is like f of x. So if I would go 2, 3, 4, okay? 2 minus 6 is negative 4, okay? 3 minus 6 is negative 3. 4 minus 6 is negative 2. Remember, x-axis means all the x's will change to opposite, okay? So 2, 3, 4, and all the y's would stay constant. Never mind, lost my train of thought, okay, with that. Okay, just change your x to the opposite. That's all that does, reflection in the x-axis, okay. I was going to elaborate on something, and the elaboration was ill-conceived, okay. Just reverse the sign on only the x term, okay. Basically, you're just making your x into a negative. Okay, the y-axis, reflection of the y-axis. Y-axis, you not only change the x term, but you change any constant or any other term. All the terms go opposite. And the thing is, if I graph that, and I graph the original and made tables for both of them, the only thing that would be changed is the y's would be opposite. Okay. Okay, reflection in the y-axis. Okay, y, you're changing everything. Sometimes it would be the same thing in the x as it would with the y. Okay, so f of x equals negative 5x. Reflection in the x-axis, we only change the x, not the y. Okay. So make a long story short, x-axis reflection, only the x term goes opposite. A y-axis reflection, then the whole entire function, everything in it goes opposite. Okay. Alright, now I'm going to show you kind of why this works the way it does. You don't have to write this down. I'm going to make two tables, x, f of x. Instead of y, I guess I'll put f of x. You don't have to write this down. I'll just quickly go 2, 3, 4. And then over here, remember, x-axis, everything opposite. Negative 2, negative 3, negative 4. The y should stay the same if I do that. Okay? So 2 times 2 is 4, plus 4 is 8. 2 times 3 is 6, plus 4 is 10, and then it's going to be 12. Now let's put these into the inverse, or the reflection. Well, negative 2 times negative 2 is 4, plus 4 is 8. Negative 2 times negative 3 is 6, plus 4 is 10. Negative 2 times negative 4 is 8, plus 4 is 12. So you see, when I have the two functions together, really the only thing that changes is that the x goes negative. Okay, I just kind of proved it. Okay, heck, I'll even do the y-axis. Don't have to write it, just watch. So f of x is like y. It's the same gosh darn, I could say another word on camera thing. Okay, so I'll do the 2, 3, 4 again, 2, 3, 4. Now y-axis, the only thing that should change is the y values. Okay, so the original one said 3x plus 4. 3 times 2 is 6, plus 4 is 10. 3 times 3 is 9, plus 4 is 13, and then 3 times, and then you're going to get 16. Now let's plug them into the invert, or the reflection. Negative 3 times 2 is negative 6, plus negative 4 is negative 10. Notice a pattern here. Now it's all the y's that'll be inverted when I do this with this. Negative 3 times 3 is negative 9, and then you're going to get negative 13, negative 16. Okay, that's proving why it works. You don't need to do that. This is all I need with the reflections. Okay, so x-axis, just change your x term to opposite. Y-axis, you can change the entire function to opposite. Not only the x, but anything with it. Okay, next up. Write an equation for each translation of y and x. Stretches and compressions. Y equals x. All a stretch and compression means is you multiply your x factor by 5, so 5x. Stretch 3. Stretches and compression mean the same thing. If it's by a factor that's greater than 1 whole, it's called a stretch. If it's by a factor less than 1 whole, it's called a compression. Because a stretch makes a graph narrow, a compression makes it wider. That's all you do. Okay, last problem, last set. Write a function rule g of x. So I want everybody to write g of x equals right there. And you're going to make the following transformations of the graph f of x equals 4x. So you're going to want to write that both times. Translate 2 units down, okay? So that's minus 2. Stretch by a factor of 5. So that means multiply your x by 5, just the x. So now where are we at? We're at f of x equals 20x minus 2. Then make it reflect in the x-axis, so you just change the x to negative. Okay? So you minus 2, take your x factor times 5, the x coefficient by 5, 20x. Reflection in the x-axis means I just change the x to the opposite. So g of x equals negative 20x minus 2. Okay, next one, g of x equals, and I'm still using the f of x right there for the graph I'm translating. Okay, it doesn't say translate up or down, so no plus or minus. Compression by a factor of 1/2, so take the 4 times x times 1/2, well that's 2x. Reflection the y-axis. Well, the y-axis means everything's basically only the 2x. Okay. If there was a plus 6 behind it, the 6 would have to go negative 2 because it's a y reflection. So this is a problem where the x reflection, the y reflection would end up the same. Okay. But there you go. Okay, do the best you can on the assignment. Gut it out. Let me know if you got questions.